Hi everyone, this is Ms. Zahra and this is the last video to help you practice for the first term science exam for 2024-2025. So this section is about the second book, Unit 1, and it's only covering Lesson 1 and Lesson 2. In Lesson 1, you have to know about speed. You have to know what is speed, motion, and the energy. How does the energy change as the object moves? Okay, so let's focus on the first question, which is about the picture. So you need to know what the picture is showing. If you look at the values given, whether it's mph, which stands for miles per hour, or m/s, which stands for meters per second. These words, the slash and the p, stand for divide. And this is showing me speed. So we need to know the meaning of the word speed. Speed is a number that tells me how fast an object is going. So the important thing is you need to know that it's a number, it's a value, and it tells me how fast an object is going. If it's a big number, they are going very fast. And if it's a small number, they are going slow. And how do I find this number? I say the distance they are moving, divide by the time. So distance, divide, time. That's how we found these values. So again, the one that is very fast has a large number, large speed. So who is the fastest animal? The eagle, because its number is 33 meters per second or 73.8 miles per hour. Please make sure that both those numbers match if you are given a multiple choice question involving it. Here's some examples of questions we may ask you. Which animal is the fastest? Which one is the slowest? So again, like we found the fastest, you would look for the smallest number, and that's how you would find the turtle. Which animal has the most energy? The eagle, because his speed is the fastest. Which one has the least energy? The turtle, because its speed is the slowest. Could also ask you to find the animal with the speed of a specific number, and you'd have to find it and list the animal. Okay, so now that we know how to calculate speed, we can use it on page 21. So how do we calculate speed? Speed equals distance divide by time. And in the exam, if you get this question, the first one, you will have to look for the question and find your numbers. Distance divide time. So my answer will be 500 kilometers divide by 2 hours. Please remember to put your unit. Without the unit, the numbers have no meaning. Okay, and divide means I'm going to break this number into these pieces. So I'm going to break the number into 2 pieces, and the 2 pieces have to be the same size. All together, it will give me 500. So the same size pieces are 250 and 250. So my answer is 250 kilometers. And then I change this into a slash, that means the same thing. And I put H. So this is how you can calculate speed. Speed is distance divide time. You take the number divided by the second number, which is breaking it into these many pieces, and then you write your answer. Okay, yours will be multiple choice, so you will have to calculate and then choose the answer. Okay, I'm just going to erase this. And now let's look at the second type of question you may get from that page, and that is about drag forces. Okay, so we all know what is friction. Friction is the force that slows something down. Now, sometimes things are not touching the surface of the ground. They might be in the air or in water. And there's also a force on these that slow them down. Gravity is the force that is pulling everything down to earth. And opposite gravity, we have a force that lifts everything up inside of air or water. And this force is called drag force. If the drag force is big, it will make something fall slowly. So if drag force increases, it makes something fall slowly. If drag force decreases, it will make something fall quickly. Okay, so drag force, this force, if it increases, it will fall slowly, and if it decreases, the object will fall quickly. So please remember those words together. Drag increase, we will get a slow fall, but if it decreases, the fall will be quick. So let's look at an example of a question that was in your paper. Over here, if the drag force increased, object falls slowly. And the last one, perhaps they may ask you to describe the object's motion, or they may give you a list of things and tell you which one can be used to describe the object's motion. We use distance, time, and direction to describe an object's motion. So the one that can not be used is temperature. Okay, now we're going to look at speed. On page 39, you will also have a multiple choice question. Maybe it will be this one, because it's already there, but it might be number 1 or number 3, put into the form of a multiple choice question. So let's look at the actual question and then see how they could ask it to you and what you could put. The first question was about the relationship between speed and energy of an object. And they were talking about, there was an inquiry activity, there was a ball on a ramp, and then we lifted the ball higher, and we want to know what happened to the energy. So anything that you lift higher up, when you lift it higher up, you will increase its energy, its potential energy. So as you lift something higher up, you will increase potential energy. So over here, I'm just going to write the 2 kinds of energy we get, because maybe if you are not sure or you have forgotten, you might forget the keywords. Okay. So energy is anything that lets us do work. It's the ability that allows us to do work. If we can do work, we have energy. There's 2 kinds of energy. Some energy that is stored. Stored energy, we call it potential. Stored is like we're keeping it. It's inside of something, but it is not moving. So stored, the energy is inside something. It's not moving. It's usually inside something that is high, and if we lift it higher, it becomes even more. Then we have energy that's moving or in motion, and this energy is called kinetic energy. Kinetic energy is in anything that's moving. So I'm just going to draw a picture of a car. Car is zooming along. And as it's moving, it has kinetic energy. If it moves faster, the speed will increase. So if speed increases, it will increase the kinetic or moving energy of the car. So faster speed means you will increase your moving energy. And if I lift something higher, I will increase my stored energy. I'm going to put a P over here for potential energy, and I'm going to put a K over here for kinetic energy. Both of these. If I make my object, my thing, more massive, that means I make it bigger. If I make it bigger, both of my energies will increase. So anything that is bigger will have more moving energy and more potential energy. And anything that is faster has more kinetic energy. Anything that's higher has more potential energy. So over here in number 1, they want to know what is the relationship when we move it higher. What happens to the energy? Well, we increase the potential energy because we moved it higher. And what happens when it's moving faster? It has more energy of motion. That's the 2 points we listed. What happens to a plane that's flying in the sky? So when a plane is flying in the sky, it's high, and something that's high is potential energy. Another word for potential is stored. So over here we see stored. Over here we see stored. It's also moving. Flight means it's moving. So it's moving, so it also has energy of motion. So it has both stored energy and energy of motion. The last question says, what happens to the amount of energy a cheetah has if it is faster? If something is faster, it's going to be equal to greater, more energy. Okay, so this will be multiple choice. So please remember the words that mean more, greater, more, increase. These words go together. Okay, the last question from this lesson is about balanced and unbalanced forces. So to explain balanced and unbalanced forces, we're going to use this simulation. Force we know is a push or a pull. So if you see the word push or pull in the question, they are talking about a force. So let's say I have this boy on the side. He's exerting a force to the left. And the red is exerting a force to the right. And I press go. I see that nothing's happening. So let's give them numbers. I have 50 to the left, 50 to the right. When forces are equal in size, the number is the same. They are equal in size, but opposite in direction. We call these balanced forces. So when forces are balanced, when we add them together, if they are acting in opposite direction, I subtract. So I say 50 minus 50 and I get 0. If my sum of my forces, when I add them together, I get nothing, I get 0, then my object is not going to move. It will stay in the same place, or if it's moving, it will keep moving the same amount. It's not fast, it's not slow. Another word for that is no acceleration. So balanced forces, there is no acceleration, there is no net force. The object keeps its motion. But if I have an unbalanced force, so if I take this and I add a force, now I have 200, which is bigger than 50. And we can see that it moved to the right. So when I have an unbalanced force, when my numbers are not equal, I will get net force, and the net force is the direction that my object will move in. So because to the right, the number was bigger than the left, it went to the right. And we say it will accelerate. Accelerate means we'll go faster or slower in that direction. So here's an example of how you can add or subtract the forces. So if the forces are on the same side, we add them together, and that's my net force. If they are in opposite directions, I subtract them to get my net force. If I have a net force, if there is a number here, then I have an unbalanced force. So if I get a number that is not 0, my force is unbalanced and I will have acceleration in the direction of the net force. But if I have a balanced force, I will get a 0 and it will not move. Okay, so what can an unbalanced force do? It can do 3 things. It can make something go faster, speed up. It can go slower, slow down, or it can change direction. The last information on this page is about this word, inertia. Inertia is a property. That means everything has it, something they have. And all it means is that things want to keep their motion. If they are moving, they want to keep moving. And if they are not moving, they are at rest. They want to stay at rest. That's all that this word means. And that was the last thing that we had to learn for the exam. Good luck and please practice all the problems I put for you.